Okay, so we are going to look at the rules for determining significant figures. So yesterday we talked about uncertainty of measurement, and we talked about accuracy and precision. So you can only be as sure as the number of significant figures that you have. So on your notes page, first rule says that non-zero digits are always significant. So how many? So in the first one, 7, that's one significant digit. 77 has 2. 777 has 3. The next one, 56,893 has how many? 5. And then 0.233246777 has how many? 10 significant digits. So in your notes page in front of you, how many does 5.98 have? 3. So write 3 on your sheet in that far right column, please. No, that's why I gave you the sheet so that you could just add it into your notes. Okay. Any questions about the rule number 1? Rule number 2. Zeros between non-zero digits are always significant. So if you have 10,002, how many significant figures are there? 10,002. 10002. 5. 808. How many are there? 3. 378,005. 6. So what about 700,043? That's on your sheet. Also 6. So right in that last one. So those zeros are called trapped zeros, and they count because they're in between non-zero digits. Kind of like, remember we had 2000 or 2.006 last week, or 2006? Same thing. Those zeros are trapped. Any questions about rule number 2? Okay, rule number 3. Zeros in front of non-zero digits aren't significant, so you would not use them. Zeros in front of non-zero digits. So in 0.458, how many significant digits are there? 3. In 0.0045221, how many are there? 5. In 0.00000000011, how many are there? 2. And then in the one on your notes page, 0.00532, how many? 3. Leading zeros don't count. Ready for number 4? Zeros both at the end of a number and to the right of a decimal point are significant. So in 23,500, how many significant figures are there? 7. What about 150.0? 4. What about 89.00000? 7. What about, tricky one, 0.0025000? 5. Good. What about 0.500008000? 9, because they're after. They're all after the decimal point. What about the one on your chart? Yep, there are 5 in that one. Why in that 0.0500008000, why are those significant, the last zeros? Because they're to the right of the what? Decimal point. So that is as sure as you can be. Does that make sense? When you're measuring, you want to be as sure as you possibly can. And whenever you have those to the right of the decimal point, that makes your measurement more sure, more complete. Yeah. All right, number 5. Zeros at the end of a number with no decimal are not significant. So in 8,260, how many are significant? 3. What about 100? 1. 10,000? 1. 52,640? 4. What about the last one? 3. What about the one on your paper?
2.
21,000 has 2. Any questions on 4 or 5? Number 6. Zeros at the end of a number with a decimal are significant. So even if there's like not 0.00 after it, if it's just 50 point, how many are significant? 2. 500 decimal. 3. 5,000 decimal. 4. 20.0. 3. Because it's still to the right of the decimal. That's a tricky one. What about 200.00? 5. What about 60.0040020? 10. What about 4,300 decimal point? 4. Any questions about those? Okay, we're going to do a few more practice using these rules. I'm going to bring that to you.
Abby gets her first.
Okay, so take a couple minutes and see how many you can try. And then we're going to talk about these because I just want to make sure we got it based on the rules. And I need to... Okay.
Just thought I'd let you know.
Thank you.
You're welcome. I won't be back till the 30th.
Okay. Bye, Andrea. About one more minute. See how many you can get in that time. Okay, let's look at some of these. Number 1, how many? 4. Number 2, how many? 2. Yeah, leading zeros don't count. Leading zeros don't count. Number 3. 2 of them. 8 and the 9. What rule number is that? You could either do lagging zeros without a decimal or just all non-zeros. Either one applies to that. So correct that if you got it wrong. Number 4. 4. 9, 1, 0, 1. Because the last one is a lagging zero. There's no decimal point there. What about number 5? 5, because there is a decimal point there. What about number 6? 8. All the zeros, the trapped zeros and the zeros after the decimal point all count. What about number 7? 3. Leading zeros do not count. These next two should be easier because they're already written in scientific notation for you. So, how many in number 8? No, whenever you're writing in scientific notation, you only use the sig figs before in your coefficient. So 2. What about number 9? Also 2. Well, it just depends. However many are in the coefficient, that's your number of sig figs. So in number 10, how many? 4. What about number 11? 2. Leading zeros don't count. What about number 12? 6. The last zero is a lagging zero, doesn't count. What about number 13? 3, because there's a decimal point. 14? 14 is 1. What about 15? 6. Because the last zero comes after a decimal point, and all zeros after a decimal point count. What about 16? 1. 17? 3. 18? 3. 19? 4. And last one? 2. Did we get a little better at them as we went?
Yeah.
Or
I felt so great at the end.
we're going to do some more practice with these tomorrow, but that's the last thing we're going to do for today. So please make sure that you keep these in your binder